Okay, so we're going to record from Electrostatics 2, the free response. There's only one of them, so it shouldn't be a real big deal. Okay, so it says you have a charge that is suspended between two charged plates. The upper one is positive, and there's a picture of it that you have access to. The lower one is negative, and they just put this Q in here somewhere. Not necessarily midway between, it's just in there. I know these plates are 0.05 meters apart, and that they're hooked up to a battery. Something like that, and the battery is 12 volts. Now, they say to you, place a check in one of the blanks below indicating whether the charge is positive, negative, or neutral. Well, if it's suspended and it's just hanging there, then if gravity is pulling down like that, the charge must be experiencing a force in that direction because of the attraction to the positive plate, so that means this charge must be negative. Okay, and so when you justify your answer, you go through and say in words what everything I just said. Charge is suspended. Downward pull of gravity. Must be balanced by upward electric force. So that means charge is attracted to the positive plate. To positive plate. So Q is negative. All right? Okay, so I'm going to get rid of that, and we're going to go on. Okay, so as we move on, Part B says on the diagram above, draw an arrow to indicate the direction of electric force. Well, we already did that. We proved that it was being pulled up. Now, if I were taking the AP test, I'd roll all the way back up here, and I'd draw one. But that's what we already know because we did Part A. Okay, Part C says, lots of parts on C, 1 and 2. It says the mass of the charge given to us and find the electric force acting on the charge. All right, well, we already said that F, electric, was equal to force of gravity. So the mass is 5 times 10 to the minus 4 kilograms. Gravity is pulling at 9.8 meters per second squared. So the force is 4.9 times 10 to the minus 3 newtons. Okay, so that's no big deal. Pretty easy to do. Now they want us to go on to Part 2 of letter C, and it says find the magnitude of the suspended charge. All right, well, let's do that. So we're looking for Q. Well, we know the electric field E is equal to F over Q. Or we could say that Q is equal to F over E. All right. Well, we already found the force. It was 4.9 times 10 to the minus 3rd newtons. Now we need the electric field. Well, the plates of a battery have an electric field between them, and that electric field is equal to V over D. So we know we had a 12-volt battery that it was hooked up to, and they were 0.05 meters apart. So we know the electric field between them is 240. So now I'm going to substitute that in over here. And so if I do that correctly, I have to think about this math now. So I'm going to pause and get my calculator, and then actually, yeah, we got it right here. All right, so let's clear that little rascal out and say 0.0049 divided by 240. And we get 2.04 times 10 to the minus 5. So Q is equal to 2.04 times 10 to the minus 5 coulombs. Okay? So there's the magnitude of it. All right. Then it says the same charge is removed, so let's get rid of that writing. We'll just mark Part D up here. From between the parallel plates and replace with a proton of mass 1.67 10 to the negative 27 kilograms. If the proton is accelerated from rest with the same accelerating potential, in other words, the voltage doesn't change, calculate its speed when it encounters one of the plates. indicate which plate the proton will move toward. Well, we know it's positive. It doesn't like the positive charges on the top plate, so it has to move toward the bottom plates because the bottoms are negative. Alright, so I can do this a couple of ways. I can say that it's going to have some work done on it, and the work done is equal to VQ, and the work done is equal to the change in kinetic energy. So 1/2 mvf squared minus 1/2 mvi squared is equal to the voltage times the charge. Well, it starts from rest, so we can get rid of that. So 1/2 1.67 times 10 to the negative 27th kilograms times V squared is equal to the voltage of 12, charge of 1.6 times 10 to the negative 19th coulombs. And so I can go do all this fun math, and again, my calculator's kind of cheesy. All I have is that little crappy one right there. So I'm going to go away and find out what it would be if I had a real calculator, and then I'll come back and give it to you. Okay, so it should be 4.8 times 10 to the 4th meters per second. So check me and make sure that I think I'm good to go. You could have also said F is equal to ma. We found the force already. You know the mass. You could find the acceleration. Then you could say Vf squared equals Vi squared plus 2ad. This would be 0. This distance it would move would be the 0.05 meters. Is what they were expecting you to use. Okay? All right. I will post this one as well.